Now we look at the example 1 for the question of continuity. So in this question, find the value of k using the definition of limit. So in this question, we will try to find the value of k using the definition of limits. Before this, let's look at the question. Given that fx is a piecewise function. So for the first function, when x is less than -2. For the second function, which is kx squared minus 4, x is greater or equals to -2 but less than 2. This is the second range. And the third function is when x is greater or equals to 2. The first question, find the value of k such that limit for fx when x approach -2 exists. Using the value of k in A, determine whether the function is continuous at x is equals to 2. So before we try to answer this question, so it's better that we start with try to drawing the real number line. So now we have -2. Another value is 2. When x is less than -2. So when x is less than -2, so means that on the left hand side of -2, the function is x squared minus x power 4 minus 16 over x plus 2. So the first function when x is less than -2 is x power 4 minus 16 over x plus 2. When x is greater or equals to -2 but less than 2, means that in the second interval, the function will be kx squared minus 4. So in the third interval, when x is greater or equals to 2, and when x is greater or equals than 2, so the function is 16 minus 5x cubed over x. So here is 16 minus 5x cubed over x. So let's look at question A. Find the value of k such that limit of fx when x approach to exists. In order for a limit to exist, the limit when x approach, so again, in order for a limit to exist, as we learned before, left hand limit must be equals to the right hand limits. In other words, means that limit when x approach -2 from the left hand side for the function of fx must be equals to the limit for x approach -2 from the right hand side in order for the limit to exist. So first, we try to find the left hand limit and the right hand limit. So limit when x approach -2 from the left hand side. So here is our -2 from left hand side. So from left hand side is this function. So means that our function is x power 4 minus 16 over x plus 2. So if you try to substitute -2 into this function, you can try to substitute, we will get 0 over 0. So let's say I show you in the denominator, -2 plus 2 is 0. So what we have to do is we try to factorize and simplify. So next I try to factorize and simplify limit when x approach -2 from the left hand side. So when I try to factorize, here is x squared minus 4, x squared plus 4 over x plus 2. So from here, you can see that we cannot cancel out this function. But when you look at x squared minus 4, again we can factorize x squared minus 4. So I factorize again. Limit when x approach negative 2 from the left hand side, x minus 2, x plus 2, x plus 2, so x squared plus 4 over x plus 2. So from here we can simplify. So here x plus 2, x plus 2. So limit when x approach negative 2 from the left hand side, what we have here is x minus 2, x squared plus 4. Then we substitute the value. So negative 2 minus 2, and then negative 2 squared plus 4. From here, negative 2 minus 2 is negative 4. Multiply by negative 2 squared is 4. 4 plus 4 is 8. So here we should have negative 32. This is the limit when x approach negative 2 from the left hand side. Next, I will try to find the limit from the right hand side. So limit when x approach negative 2 from the right hand side. So here is the function when x approach negative 2 from right hand side. Here is the right hand side. So the function is kx squared minus 4. So when I substitute, so here is k negative 2 squared minus 4. So here I should have 4k minus 4. As we learned before, in order for a limit to exist, so here is the limit. In order for the limit to exist, left hand limit must be equals to right hand limit. Therefore, 4k minus 4 must be equals to negative 32. 4k must be equals to negative 28. K is equals to negative 7. So this is our first answer, the value of k, which is negative 7. Go to question B. Using the value of k in A, so our value of k in A is, so our value of k here is, so where our k is negative 7, so our value of k is negative. So this function now will become negative 7 x squared minus 4, because our value of k is negative 7. Now we continue with question C. Question B, using the value of k in A, determine whether the function is continuous at x is equals to 2. So for question number B, x is equals to 2. Continuous, whether continuous is x is equals to 2. So there are three conditions that we're going to meet. So the first condition, FA, where in this question is F2. So if you refer to the range, there are two value included. There are two value in here is which is 2. So which one we going to choose? So the question is which function or which interval that we're going to choose. So what we're going to do is we try to look at this value. Let's say, so here, this means that it's not included, means that it's not included 2, whereas here is included. So my question is which one we should choose? Since here is included, so we're going to choose the included 2, not this one, because this one is not included 2. So here is the function that we're going to choose. This is the function that we're going to choose because this interval is included 2. So next, I substitute into the function which is 16 minus 5 2 cubed divided by 2. So by using your calculator, so 16 2 power of 3 is 8. 8 times 5 is 40. So 16 minus 40 divided by 2. So here is negative 12. You can use your calculator to calculate. 16 minus 5 times 2 power of 3. Get your answer. Divide by 2. So it's negative 12. So the first condition is negative 12. Now we go to the second condition. We try to find the left hand limit and the right hand limit. Limit when x approach 2 from the left hand side. So here is 2 again. Here is 2 when we approach from the left hand side. So the function is negative 7x squared minus 4. So here is, so the function is negative 7x squared minus 4. So we try to substitute negative 7, 2 squared, negative 7 times 2 squared minus 4. So here is negative 28 minus 4, which is equals to negative 32. Then we try to find the right hand limit. Limit when x approach 2 from the right hand side. So here is 2, right hand side. The function is 16 minus 5x cubed over x. Actually, we already substitute the value here, which is this function. So here is, let's say, 16 minus 5, 2 cubed over 2. So here is negative 12. You can see that the left hand limit is negative 32. The right hand limit is negative 12. So what does this tell us? So means that, therefore, limit when x approach 2 for the function of fx does not exist. So the limit for the function of fx when x approach 2 does not exist. So now comes to the third condition. So third condition is we compare the first condition and the second condition. So let's say I write in this form. In the first condition, f2 is equals to negative 12. In the second condition, limit when x approach 2 for the function of fx does not exist. So the first condition, f2 is negative 12. Then for the second condition, f limit for the function of fx when x approach 2 does not exist. So in the third condition, since f2, this means that the first condition, since f2 is not equals to the limit when x approach 2 for the function of fx, so fx is not continuous. At x is equals to 2. So you need to solve these three steps. First condition, second condition, and the third condition we compare. So of course this part is optional. Means that you can skip this part. So you can straight forward to the explanation.